We're about to move on to Newton's method, but before we do, let me just quickly explain to you the equation of a straight line. So suppose you have a straight line here where the intercept here is 2 and the gradient here is 3. Okay, so let's say you've got this same line, but you only happen to know the gradient, and you only happen to know that it passes through one particular point, 2, 8. Okay, so our normal method of coming up with the equation of a straight line would be to start out with y equals mx plus c. We know m here, so we would put this into here. We know this is our x here. We know x and we know y. Then we can work backwards to find out c. Okay, so this is our normal method. But another way of doing it is that if you know the gradient of this line here, and you know it passes one particular point, you can't just jump straight to this. So you can just say, well, when you know the gradient of a straight line and you know it passes through one particular point, you can just jump to this. Or another way of visualizing this is to, when you're here, multiply both sides by this thing here. So it will then give you this. Okay, so this is another way of coming up with the equation of a straight line, given the gradient and one particular point that it passes through. So hang on. So in this case here, this is our m here. We can put this into here, and then this is x here. So we can put this into here. This is our y here. So we can put this into here. Okay. So in this particular case, the gradient is 3. We know that. Well, when given the gradient, when given a gradient and when given that it passes through one particular point, we can just say, oh, well, the gradient equals y take away 8 and then take away 2 here. So you would then multiply both sides by this thing here. That would then give you this, and then add 8 to both sides. That will then give you this. Tidy up, it will then give you this. So this is another way of coming up with the equation for that straight line here. Okay, so in summary, whenever you know the gradient, when given m equals whatever, whenever given the gradient and you know it passes through one particular point, you can just jump straight to here. Okay, or the same thing here, multiply both sides by this, it will then give you this. So you can either jump straight to here, or you can jump to here. And the reason why it works is because of this. Hang on. The reason why it works is because normally, suppose you're given a straight line and it passes through two points. So normally we would start out with y equals mx plus c. We need to know the gradient. So in this case, we would need to get the height here divided by the across here. Well, the height here would be this take away this. It would be this take away this, and the across here would be this take away this. So that's our normal method. Our normal method was to get one point to take away the other. So in this case, it would be this take away this, and then divided by this take away this. And then if you look at this, if you look at the situation here, hang on. We've been given the gradient, and we know it passes through one particular point. Well, let's just say, well, here the gradient's 3, and then let's just say one particular point. It could be any point on the line. Let's just say it passes through x, y, any point on that line here. So you would say, oh, the gradient is 3, and then well, the gradient would be the up and down, which would be y take away 8, and then you would divide it by the across here, which would be x take away 2. So you see, this is in a way like m equals y take away y0 divided by x take away x0 here. The reason why it works is up here. Hang on. Up here, you would just get one point, take away the other point, and then from that you can work out your gradient. Well, down here, you know the gradient But then you can select any point on this line here. Let's just say this point happens to be any point, so it can be x comma y. So you would just get this take away this, y take away 8, and then this take away this. So here in a way is like m equals y take away y0 over x take away x0. And by the way, this xy thing will even work. Will still work even if it's down here somewhere. It will still work. Okay.